description of motion involves the representation of a restless world. Nothing is ever perfectly still. You may sit, apparently at rest, your blood flows, and air moves into and out of your lungs. We'll define motion and explore the ways of describing it. We'll also learn to analyze changes in motion, speeding up, slowing down, and stopping. Displacement is a straight line distance between 2 points along with the direction, given by change of x is equals to x sub 2 minus x sub 1. Speed: when something is in motion, its position changes with time. Both length and time are therefore important quantities in describing motion. This can be expressed by using length and time to give the rate at which distance is traveled, or speed for each. Average speed is the distance traveled divided by the total time elapsed in traveling that distance. Another quantity used to describe motion is velocity. Speed and velocity are often used synonymously, but the terms have different meanings in physics. Speed is scalar and velocity is vector. Scalar means it has no direction. The average velocity is displacement divided by the total time traveled. Velocity is equals to change in displacement over change in time. So let's go to the problem solving. Example number 1, a jogger jogs from one end to the other of a straight 300-meter track from point A to point B in 2.5 minutes and then turns around and jogs 100 meters back toward the starting point to point C in another 1 minute. So the question is, what are the jogger's average speeds and velocities in going letter A from A to B and letter B from A to C? It's not the multiple choice, okay? Let's solve first the letter A. The first step in solving a problem is to analyze. Second, list all the given of that problem. So we have a 300 meter for displacement, distance, and 2.5 minutes for time, and let's convert the 2.5 minutes into seconds. So the formula of speed is equal to distance over time. And now let's place all the given into that formula and solve. So we got a 2 meter per second. Just like what I told earlier, velocity is a vector quantity. It has a direction. Since in letter A, the direction is only in one way from point A to point B, the value of that velocity will only change if there's a change in direction. Let's solve the letter B for better. Let's first solve for speed. Speed is equals to distance over time. 300 meter plus 100 meter because the jogger turns around and jogs 100 meter back toward point C. The speed doesn't mind the direction. And the answer here is 1.90 meter per second. Let's now solve for the velocity. 300 meter minus 100 meter. Why? Look at the drawing. The 300 meter is going to the right, while the 100 meter is going back to the left. If there's a change in direction and velocity, we must subtract them. The basic description of motion involves the time rate of change of position, which we call velocity. Going one step further, we can consider how this rate of change. Suppose that something is moving at a constant velocity and then the velocity changes. Such a change in velocity is an acceleration. We define acceleration as the time rate of change of velocity. Acceleration is equals to change in velocity over change in time. Example, an automobile traveling on a straight road at 90 km per hour slows down to 40 km per hour in 5 seconds. What is its average acceleration? For example 2, the given is 90 km per hour for the initial velocity, 40 km per hour for the final velocity, and 5 seconds for the time. So here, what is the acceleration? First, we convert the velocities in meter per second. 90 km per hour into 25 meter per second, 40 km per hour into 11 meter per second. After converting, let's all place all the given to the formula, and the answer is negative 2.8 meter per second squared. Why negative? Because it accelerates or slows. These are the kinematics equation. S stands for distance, V stands for velocity, V sub O means initial velocity, V sub F means final velocity, A stands for acceleration, T means time. These equations are the formulas for the whole kinematic problems. In order for you to memorize all these formulas, we need to create a mnemonic or something related so that it will be easier for us. If you're a Filipino or if you can understand the language of a Filipino, then you can use our mnemonics for all of these formulas. The last three formulas are the main formulas. So for the V sub F minus V sub O equals to A times T, the mnemonic for this is may BF siya na may VO ang tapak. For the second formula, may dalawa siyang VF na may dalawang VO at dalawa ang susi. For the last one, si VOT ay kalahati ang T square. You guys can also do the same. Create a mnemonics now. A ball is dropped out of a window near the top of a building. If it accelerates toward the ground at a rate of 9.8 meter per second squared, what is its velocity when it has fallen 4 meter? And these are the choices. Okay, a ball is dropped out of a window near the top of a building. The acceleration here is the 9.8 meter per second squared, and the height of that building is 4 meter. And the question is, what is its velocity? Let's list first all the given. Acceleration is 9.8 meter per second squared. Height or the distance of a building from the window to the ground is 4 meters. Its starting velocity is automatically 0. What is the final velocity? Remember the kinematic equations. What do you think is the right formula given that we have an acceleration, distance, and the unknown is velocity? Is the first and third formula the correct one? No, because we don't have a given of time. What about the second formula? Yes, it's the correct one. So let's place all the given to that equation and solve. So the answer is 8.85 meter per second. So another example, a race car starting from rest accelerates at a constant rate of 5 meter per second squared. What is the velocity of the car after it has traveled 1 times 10 raised to 2 feet? This is also the same from the previous example. The given are initial velocity is 0, acceleration is 5 meter per second squared, distance is 1 times 10 raised to 2 feet. So the question is, what is the final velocity? We must first convert the distance into meter. So 1 times 10 raised to 2 feet is equivalent to 30.48 meter. So the formula that we will use is also the second one. So let's place all the values and solve. Another example which is complicated. Cardo was traveling at a constant speed of 24 meters per second, passes a lakdan hidden behind a billboard. 1 second after Cardo passes the billboard, a lakdan sets off in chase with a constant acceleration of 3 meters per second squared. So to better understand this problem is animated. 2 boys, Cardo and lakdan, are behind of a billboard. Cardo has a constant speed of 24 meters per second. Lakdan has an acceleration of 3 meters per second squared. The solution for this is at Cardo, use the formula of SED. S is equals to velocity times time. Cardo has a velocity of 24 and this is the equation number 1. At Alakdan, use the third formula. Alakdan has an acceleration of 3 and the time will be t minus 1. Why t minus 1? Because it says from the problem that 1 second after Cardo passes the billboard, Alakdan set off in chase. It means that Alakdan has a 1 second delay after Cardo passes the billboard. At Alakdan, this will be the equation number 2. Let's put the equation 1 to equation 2, so we now have this new equation. To solve this, we will just need a calculator. Get a calculator and listen to my tutorial. Type the equation into the calculator. Just find those x and equals to your calculator, okay? So press 2 for alpha x, then alpha equals, then 1/2, open parenthesis, 3, then close parenthesis, then another open parenthesis, then alpha x minus 1, close parenthesis, then after inputting the equation into that calculator, press the shift solve, then press 24 to the solve for x, then press the equals. Your calculator will process that equation. So the x will be 17.94 and that will serve as your time in seconds. Our solving will not end here. Now subtract the 1 to t and that will be the time of Alakdan. Use the formula BF minus VO is equals to acceleration times time and substitute all and solve. The answer is 50.81 meter per second. Try to solve for this and it's exactly the same from the previous example about Cardo and Alakdan. You can pause this video to understand the problem. And these are the answers.